Hello dear students, our lesson today talking about comparing and ordering rational numbers. First of all, let's understand how to represent rational number on the number line. For example, if we want to represent rational number like 3 over 4 on the number line, then we need to understand something. That 0 equal 0 over any number. If you have a fraction with numerator 0, then the whole fraction equals 0 as we explained in the previous lesson. Then 0 equals 0 over 4, 0 over 5, 0 over 7, and so on. And 1 equal 4 over 4, 2 over 2, 9 over 9, 13 over 13, any number divided by itself. Okay, then to represent this 3 over 4, this rational number on the number line, then we can figure out that this fraction including between 0 over 4 and 4 over 4. We will make two fractions like that with the same denominator with the same denominator 4, and we will put here 0 because 3 is bigger than 0 and smaller than 4. That means 3 over 4 is in between 0 and 1. This represents 0 and this represents 1. Okay, then 3 over 4 is in between 0 and 1. Let's draw a number line, okay, like that. Since 3 over 4 is in between 0 and 1, then this is 0 and this is 1. After 0, we will count 4 units because here the denominator is 4. Then after 0, we will count 4 units. 1, 2, 3, and 4. Okay, again, between 0 and 1, we will count 4 units. 1, 2, 3, 4. Why we counted 4 units? Because the denominator is 4. And the third part, this is represent 3 over 4. This 1 over 4, 2 over 4, and this 3 over 4. How to represent this fraction 7 over 5 on the number line? We need to remember that 1 equal any number divided by itself, like for example 5 over 5, and 2, this equal 10 over 5. Then to represent this 7 over 5, you will find 7 over 5 is in between 5 over 5 and 10 over 5. 5 over 5, this is equal 1, and 10 over 5, this equal 2. Then our fraction including between 1 and 2, then we need to draw number line, and between 1 and 2 we will divide 5 parts, because as we said, according to the denominator we will divide our parts. Then after 1 we will count 1, 2, 3, 4, 5 parts, and the second part, this represents 7 over 5 because this is 5 over 5, 6 over 5, and this represents 7 over 5. Okay, let's represent these numbers: 3, negative 3 over 2, 5 over 2, 0, and negative 4, and let's put them in order ascendingly. First, we will draw our number line. We know the position of 3, this is 0, okay, and this is 1, this is 2, sorry, this is 2, and this 3. Then we will represent our number 3 here. 5 over 2, this is equal 2 and half. Then between 2, okay, between 2 and 3. 0, we know this 0 in the middle, okay, this is negative 1, and this is negative 2, and this is negative 3, okay. 3 over 2, or negative 3 over 2 is in the half between negative 1 and negative 2, in the middle or the halfway between them. And finally this is negative 4, and we can put them in order ascendingly from left to right like that. Then our order, it's gonna be negative 4, negative 3 over 2, 0, 5 over 2, and 3. How to compare between two numbers like that? Here, for example, by looking at this 7 over 12 and 5 over 12, it's very easy to compare because both of them the same denominator. Then 7 over 12 is bigger than 5 over 12. What about if we have two fractions with different denominators and numerators like that? We can make scissors like 1 over 4. We will make 4 times 3 and 12 times 1. You will get 4 times 3 equal 12 and 12 times 1 equal 12. Since both of them are equal, then the comparing between these two fractions the same equal. Let's compare between 3 over 7 using the same way, scissors. Okay, 3 over 7 and 1 over 4 using scissors. You will get 7 times 1 equal 7 and 4 times 3 equal 12. Then 3 over 7 is bigger than 1 over 4. This is the same way. 3 times 6 equal 18. 12 times 2 equal 24. Then 2 over 3 is bigger than 6 over 12. Here we want to make both of them the same. 11 over 2, we can write it as a decimal, 5.5. Then 5.5 is bigger than 3.2. Okay. 3 over 8, we can make it decimal, or we can write the percentage as a fraction. If we want to write 3 over 2 over 8 as a decimal, we will get 0.375, and the other one 0.23. You will find that 0.375 or 3 over 8 is bigger than 23%. 1 over 4 and 1 over 6 also we can make scissors between them to get the correct answer. 6 times 1 is 6, 4 times 1 is 4, then 1 over 4 is bigger than 1 over 6. The other question, negative 5 over 7 and negative 3 over 2, also we will make scissors between them. 2 times negative 5, be careful, this is negative. 2 times negative 5 is negative 10. And 7 times 3 is negative 21. Then negative 10 is bigger than negative 21, or our fraction negative 5 over 7 is the biggest one. To compare between these two fractions here, this is mixed. We need to make it an improper fraction. To multiply 3 by 1 plus 2, you will get 5 over 2. To make comparing between them, we will make scissors. 2 times 9 and 5 times 5. 2 times 9 is 18. 3 times 9 is 27. 5 times 5 is 25. Since 27 is bigger than 25, then 9 over 5 is the greatest one. Let's solve the other one by converting this one as a improper fraction. 2 times 3, 6, plus 1, 7. Then negative 7 over the same denominator 2. Let's make scissors between them to get the correct answer. 2 times negative 20 is negative 40. 6 times negative 7 is negative 42. Okay. Negative 40 is greater than negative 42, then negative 20 over 6 is the greatest. Let's write this fraction as a decimal, or this decimal as a fraction. This is 0.5, that equal half, 1 over 2. And this is 2 over 8, or simplest form as 1 over 4. By making scissors, you will get that half is the greatest. Negative 8 over 5, this is absolute value of negative. Make it positive. Positive 8 over 5 as a decimal, 1.6. Then both of them are equal. You can write 1.6 as fraction also. You will get both of them the same answer. How to find three rational numbers lying between 1 over 3 and 2 over 3. To get a number of fractions or rational numbers lying between both of these two fractions, by the way, there are an infinite fractions, are infinite numbers or are infinite rational numbers between any two integers or any two rational numbers. That means between 1 over 3 and 2 over 3, there are an infinite rational numbers lying between them. How to get three rational numbers? Okay, it's very easy to multiply both of numerator and denominator by 10 like that. You will get 10 over 30 and 20 over 30. Then it's very easy to choose any three fractions between them, like for example, like 11 over 30, sorry, 11 over 30, for example, 12 over 30, 13 over 30, until 19 over 30. Any three fractions between them, you can get the answer. Okay, but the first important or the most important and the first step to make both of them, or to check that both of the two fractions the same denominator, like our question. Our question here, 1 over 3 and 2 over 3, both of them the same denominator. Then the next step to multiply by 10 for numerator and denominator, like our way here. Okay, this is the easiest way. But what about if the question, for example, here as you see, we have two questions with different denominators, 1 over 2 and 1 over 3. Then the first step to make them the same denominator. Okay, this is very important to make them the same denominator. Here 1 over 2 and 1 over 3, we can make them with common denominator 6. After making them with common denominator 6, 2 over 6 and 3 over 6, in the next step to multiply numerator and denominator by 10 to make it 30 over 60 and 20 over 60, and you can choose any 3 or 4 or any number of rational numbers between them, between 20 over 60 and 3 over 60, like for example, sorry, this was the answer of the previous question, but the answer of this one, like 21 over 60, 22 over 60, 23 over 60, and so on. So here, this is very easy to get any number of rational numbers lying between fractions like that. That was our lesson. I hope it was easy, and if you please to try to watch the video one more time to understand the lesson and try to solve your homework. Thank you for listening and have a great day.